Okay, so in this lesson, we're going to look at the different forms of parabolae and quadratics in algebra terms. So the most basic one we've graphed is something like this. We've also graphed things in the form of this, and we've graphed some like, X, I want a Y. We've graphed some like this. So we're going to go through each of those three different forms and what they show us. So we'll start with this one here. This is called general form, and it's the least useful. It looks like this. All right, so this is called general form, and it only shows us two pieces of information. All right, so just like for a linear equation, it has a constant on the end. Now that constant shows us the y-intercept. All right, constants always show us the y-intercept if they are in general form, and I'll show you why that is. It's because to find the y-intercept, all we have to do is substitute x equals 0 in. So I'd have a times 0 squared plus b times 0 plus c. Now everyone should know that 0 squared is 0, so this is just going to become 0 plus 0 plus c. So you can pretty clearly see that the y-intercept is this constant on the end here, or the c value. All right, so this is called general form. It shows us the y-intercept. Okay, so we can read straight off there, whatever that constant is, then it's the y-intercept. All right, so that's the first one. The second form in the middle is called turning point form. Now, for those who don't recall, the one when we graphed this parabola looked like this. All right, and the location of the turning point was here at 2, 0. Now, it's a little bit hard to see in this example, but another example would look like something like this. You might have x plus 3 squared minus 2, and you can actually read the turning point by looking at that number and that number. All right, so to go back to the original example at the top here, if I imagine that there's a plus 0 on the end, and then look at that number and that number, can you see the relationship there? So this is the x value of the turning point, but it's the opposite, and this is the y value of the turning point, and it's just that value. So the turning point in this one would be minus 3 minus 2. All right, so this form is called turning point form, and it shows us the location of the turning point. All right, but it has to be the opposite of x and the y value. All right. Now, this one here to the right is another example of turning point form. You can see that it has a squared expression, but this one has a plus 3 where this one had a 0. The difference is that the one on the right doesn't have any sets of brackets. So what do you think the turning point might be if we look at this and say, what should the brackets be if there was to be a turning point? So think about how this, I had to put a plus 0 at the end here. What would go in there? If you just thought to yourself that it might look like this, you'd be 100% correct, because x take 0 is still x. So I could easily just simplify this whole bracket by taking out the minus 0. But this does help me find the turning point, because now I can list it as 0, 3. So I can see that it hasn't moved along the x-axis, but it has gone up the y-axis. All right, so these two, even though they look different, are both examples of turning point form. All right, so keep that locked away in your mind. Now, the last one we're going to look at today is called factorized form, and it looks like this. You might see one that goes Oops, I'm going to make that a 2. Something like so. It's got two things in brackets. These are both called factors because factors are two numbers that multiply to make a third number, and you can see that whatever this set of brackets is worth, it is then multiplied by the second set of brackets to produce y. So this is called factorized form. All right, now we're going to go through some skills later on to go from or to produce factorized form. So all you need to know now is what it shows us. So general form shows us the y-intercept. Turning point form shows us the turning point. Factorized form, by process of elimination, must show us the x-intercepts. All right, so it does this through a fairly simple process. The x-intercepts can be found by calculating where the y value is 0. So if I was to do this and ask myself what values of x should produce an answer of 0, I could look at this and I could say, well, if I want this bracket to equal 0, I have to go x take 2 equals 0, so therefore x should equal 2. So if I substitute this 2 into the first set of brackets, or in place of x everywhere, I'd have 2 minus 2 and 2 plus 2. Now you can see there that 2 minus 2 would be 0, but 2 plus 2 would be 4. But then I'd multiply these two together and I'd still produce an answer of 0. So 2 is one of my x-intercepts. But there is also another, because this set of brackets is different from that set of brackets. So if I think to myself, I want x plus 2 to equal 0, so therefore x should equal minus 2. And if again I substitute minus 2 in place of x in both set of brackets, I can see that minus 2 plus 2, so I'd have 0 equals minus 4 times 0. Again, multiplying those out would produce another answer of 0. So I have two x-intercepts. One is at 2 and the other is at minus 2. All right, so this factorized form, it's one of the few ones that doesn't have a name that tells you what it shows you. You need to remember that factorized form shows x-intercepts. All right, so those are the three forms of parabola. We have general form, which shows the y-intercept at the constant. We have turning point form, which will generally have a set of brackets and a square, or just a simple x squared and a constant afterwards, and it shows the turning point. But you have to be careful to read the opposite of whatever is next to the x. Then you have factorized form, which is generally written in two sets of brackets, both having an x in them. Factorized form shows you the two solutions, or the two x-intercepts by calculating what would need to be in place of the x to make each bracket worth 0. This has a very special name, and people who are in the SEAL class last year might remember what it's called, but I will go into that in future lessons. All right, so hopefully that helps you with your card sort with the three different forms of equation.